For example 4, we got secant squared minus 2 times the tangent of x equals 4. So we already got all the x terms on the same side, which is good. But right now it's a little tricky because we have secant squared and we have tangent. I want to focus on just the secant squared. In fact, I want to go back to the previous page because, I'm sorry, not the previous page, the first page of this section, because we have something involving secant squared up here. We see secant squared is equal to 1 plus tangent squared. So effectively, we can replace secant squared with 1 plus tangent squared. So let's do that. So instead of secant squared, again, we'll replace with 1 plus tangent squared of x minus 2 times the tangent of x equals 4. Now I'm going to rearrange that left side a little bit because we got tangent squared and we got a tangent. So we're going to do tangent squared of x minus 2 times the tangent of x plus 1 equals 4. Now, this one's starting to look a little quadratic-ish, so let's get everything on the same side. So if I subtract 4 from both sides, we got tangent squared of x minus 2 times the tangent of x minus 3 equals 0. Now that left side, kind of think about it. Again, if it helps you to rewrite it as just x squared minus 2x minus 3 and just kind of factor that out. Well, x squared minus 2x minus 3, we could factor that out into x minus 3 times x plus 1. So on a related note, instead of x's, we're dealing with tangent of x's. We have tangent of x minus 3 and tangent of x plus 1 equals 0. Now, we got the zero product property going on here, so either the tangent of x minus 3 equals 0, or the tangent of x plus 1 equals 0. Now, I'm running out of vertical space here, but thankfully I've got a lot of space off to the left. So I'm going to focus on those two. Now, on this first one, let's do tangent of x minus 3. So to solve for x, I'm going to add 3 to both sides. And we got tangent of x equals 3. That's a horrible looking 0. Why didn't I fix that? There we go. Now, to figure out the tangent of x, to figure out x, we got to undo the tangent. So we're going to take the inverse tangent on both sides. And so on the left side, we're just left with x. On the right side, we have the inverse tangent of 3. Now, if we go to the unit circle, I'm trying to figure out where the inverse tangent is equal to 3. Let me clear out some of the stuff that's in here. Sorry, I'm trying to test something out here. The tangent of x equal to 3. Where is it? Well, looking at the unit circle, you'll notice I already have on here all the tangents written. That's all these off to the side here, like the square root of 3 over 3 for pi over 6. I don't see just straight up 3. So, quite frankly, we're just going to leave it. If it's not something nice and convenient on the unit circle, let's just leave it. So we're going to say x equals the inverse tangent of 3, but we also need to include coterminals. Now, I want to go back to the first page because we haven't done tangents yet. The period of a tangent is pi. So that means instead of you saying plus 2 pi n, we're going to just say plus pi n. Or, if you want it, there's another way you can write inverse tangent. You can say arctan of 3 plus pi times n. So either of those answers works. I'm going to write that box down there. Now we also need to do the other one. We have the tangent of x plus 1 equals 0. So to solve for x, I'm going to subtract 1 from both sides. I got the tangent of x equals -1. Now at this point, again, you can apply the inverse tangent or you can just kind of eyeball it. You're saying where on the unit circle is x equal, where on the unit circle is the tangent equal to -1? Now on this unit circle that I've got filled in already, we've got 2 spots. Here's the tangent of Here's the tangent of -1. Here's the tangent of -1. So we got 2 options, 3 pi over 4 and 7 pi over 4. So let's jot that down. We got x equals 3 pi over 4 and x equals 7 pi over 4. Now, just like we did for the other tangents, we got to say plus pi times n. Actually, scratch that. We can just do that one. Because if we take 3 pi over 4 plus pi, we end up with the 7 pi over 4. So this is just a little redundant. I got a little overzealous. We only need to go with the ones between 0 and pi because every other coterminal angle is just going to be, well, plus pi n. Now for number 5, we got the cotangent of x times the cosine squared of x equals 2 times the cotangent of x. To start this off, let's get all the variable terms on one side. So I'm going to subtract 2 cotangent of x from both sides. So we got cotangent of x times the cosine squared of x minus 2 times the cotangent of x equals 0. Folks, let's factor out. You'll notice in both of those pieces, we got really two pieces. We got this first piece, cotangent times cosine squared. We got negative 2 times the cotangent. Let's factor out a cotangent from both. And when we factor out a cotangent from that first group, we're left with cosine squared of x. When you factor it out from the other one, you're left with negative 2. And we're going to set that equal to 0. So we got another group here, or another situation where one thing times another equals 0. So let's set both of those equal to 0. So we're going to say the cotangent of x equals 0 is going to be one of our options. And then we're also going to do cosine squared of x. Cosine squared of x. That's getting messy. Cosine squared of x minus 2 equals 0. Let's take care of the cotangent one first. So cotangent, it's really the reciprocal of tangent. So we're thinking, where does 1 over tangent, let me actually flip that around. Let's put it in terms of sine and cosine. It's where the cosine of x over the sine of x, kind of using those quotient identities, is equal to 0. So the only way we can get cosine over sine equal to 0 is if cosine is equal to 0. So if we look at our unit circle, there's only two places that cosine is equal to 0. That's up here and down here. Now, we're also going to realize that since it's a cotangent, it's going to have the same restriction on our domain as it did for tangent. So we're only going to look at the top half here between 0 and pi. So we're only going to worry about pi over 2. So we're going to say x equals pi over 2 plus pi times n. So again, let me go back over that. Pi over 2 and 3 pi over 2 would be answers, but this is just pi over 2 plus pi plus another pi plus another pi. So they're essentially just half circles away from each other. Now for the cosine squared one, I'm going to add 2 to both sides. And we got cosine squared of x equals 2. And we'll take the square root of both sides. And we got cosine of x equals, well, technically plus or minus the square root of 2. Now we look at the unit circle. The highest cosine value we get is positive 1. The lowest we get is negative 1. The square root of 2 is like 1.4 something. It's bigger than 1. It's outside of this domain. So technically, there are no solutions that make this true on that part, because our cosines have to be between negative 1 and positive 1. So there's no solutions for that part. So the only solutions that work are pi over 2, 3 pi over 2, 5 pi over 2, all those coterminal angles.